With school back in session, I figured I'd take a look at some questions that people were actually asking, and these come from Reddit's r/homeworkhelp. The first one I have was from someone looking to get some help understanding a handout that they got. Was using the limit as h goes to 0 of f of x plus h minus f of x all divided by h to find the slope of a tangent line. And the question asked was, how do you get from one step to the other? So we're going to fill in the missing steps in between here. Something that happens quite a bit is you'll do multiple things and then write down the changed equation once again after doing 3 or 4 different things. Was something that I was pretty notorious for as a student. And so let's start by separating what has changed from what hasn't. On both of them, we still have the limit as h approaches 0, and then we're still dividing by 0 in both situations. And in both of them, we still have the plus 3 and the minus 6 squared plus 3. So we're going to focus in on the white parts here. So we've got 6 plus h squared, which is 6 plus h times 6 plus h. And then we can split that up into 6 times 6 plus h times 6 plus h. And now we multiply and wind up with 6 times 6 plus 6 times h plus h times 6 plus h times h. And then we can simplify this a bit as 6 squared, and we'll just flip our h plus 6 around so that we have 2 6 times h terms and an h squared term at the end, and wind up with the 6 squared plus 2 times 6 times h plus h squared. That didn't take too long, so let's move on to the next one. Someone asked for the vertical asymptotes of the tangent of 5 theta divided by 2 theta. If you've ever been told that you can't divide something by 0, what happens is it shoots up towards infinity, which is where you get your vertical asymptotes. So to figure out where the vertical asymptotes are for this function, we need to figure out where the bottom part of the division here, the denominator, equals 0. So it might look like we're just dividing by 2 theta here, but our tangent function hides a division in there. The tangent of 5 theta is actually the sine of 5 theta divided by the cosine of 5 theta. So we've got the situation where 2 theta equals 0, in which case we've got one vertical asymptote at theta equals 0, and when the cosine of 5 theta equals 0. So I assume if you're asking trig questions, you probably know trig definitions, where you've got the angle and you've got the sine of the angle on your side opposite the angle, and the side that's adjacent to the angle you've got your cosine. And the cosine's going to equal 0 when the hypotenuse is going either straight up or straight down, which occurs at pi divided by 2 and 3 pi divided by 2. So for the cosine of 5 theta equals 0, we've got 5 theta equals pi divided by 2, or 3 pi divided by 2, or any of the ones for more than one rotation. So theta is going to be equal to pi divided by 2 times 5, or 3 pi divided by 2 times 5, and so on and so forth, or theta is going to equal to pi times 2n plus 1 divided by 10, where n is an arbitrary integer. So the vertical asymptotes for that function is that theta equals 0 and pi times 2n plus 1, all divided by 10. The next question I have has to do with gravity, and my paraphrasing of it is that an object on a different planet falls from rest and takes 4 seconds to drop 20 meters. And it asks what is the value of g on that planet, what's the average speed of the object, and what is the object's final speed. So someone pointed out that the problem the person was having with this question is forgetting the divide by 2 in the formula, where distance is equal to your acceleration times your time squared divided by 2. To help remember that division by 2, it helps to understand where that equation comes from. And to do that, let's start by taking a look at a more simple situation, an object traveling at a constant speed. In this graph of the speed with respect to time, you've got the straight line there representing your constant speed, and if you wanted to know how far that object has traveled, you'd take the speed and multiply that by the time, which visually is represented by the shaded area here, and that gives you your distance, a nice rectangle. So when you've got a constant acceleration, you wind up with the graph of your speed with respect to time that looks something like this. And the distance you get is can be represented by this triangle here. And on one side we have the time, and the other side we have your speed at the end. So the area of that triangle, or the distance you travel, is equal to time times the final speed divided by 2, since it's a triangle. And the final speed is your acceleration times time, which is where we get your distance is equal to the acceleration, or in this case g, since we're dealing with gravity, multiplied by time squared divided by 2. And now we just multiply both sides by 2 to get g times time squared equals 2 times the distance, and then we divide by time squared, and we wind up with g equals 2 times distance divided by time squared, which in our case is 2 times 20 meters divided by 4 seconds squared, and we get g equals 40 divided by 16, which equals 2.5 meters per second squared. So for the other parts of this, we have our average speed is going to equal the distance the object traveled divided by the time it took, which is 20 meters divided by 4 seconds. So it had an average speed of 5 meters per second. And then for our final speed, we have our acceleration multiplied by time, which is 2.5 multiplied by 4 seconds. Final speed is equal to 10 meters per second. Another question that caught my eye was this thing with 4 to the power of x plus 5 minus 4 to the power of x plus 4 equals 384. I just did something that looked rather similar, except here we only have one unknown instead of two. So let's start with the same approach and just factor out what we can. In this case, we can take 4 to the power of x out of that and have 4 to the power of x times 4 to the power of 5 minus 4 to the power of 4 equals 384. At this point, we could just plug those into a calculator and do 384 divided by 4 to the power of 5 minus 4 to the power of 4. Or we could factor that further and take the 4 to the power of 4 out of those brackets and have 4 to the power of 1 minus 4 to the power of 0, or 4 minus 1, which is 3. And that would give us 4 to the power of x times 4 to the power of 4 times 3 equals 384. At which point we kind of have to just start dividing, and 4 to the power of x times 4 to the power of 4 is equal to 384 divided by 3, which is 128, and then 4 to the power of x is 128 divided by 4 to the power of 4, or 128 divided by 256, which is 1/2. So if 4 to the power of x is 1/2, then what does x equal? I hope the reason that you're getting questions involving exponents is because you've been taught that in class, and hopefully you feel comfortable with what I'm about to say. So 4 to the power of 2 is equal to 4 to the power of 3 divided by 4, and 4 to the power of 1 is equal to 4 to the power of 2 divided by 4. So 4 to the power of 0 is 4 to the power of 1 divided by 4, and therefore 4 to the power of minus 1 is 1 divided by 4, which is one of the parts that we need to figure out what x equals. And the other part we need is the other part you're going to need is understanding 4 to the power of 1/2. So if we're comfortable with 4 to the power of 2 times 4 to the power of 1 equaling 4 to the power of 3, or 2 plus 1, and 4 to the power of 1 times 4 to the power of 1 being equal to 4 to the power of 1 plus 1, or 4 to the power of 2, then we can say 4 to the power of 1 equals 4 to the power of 1/2 times 4 to the power of 1/2. And what number can you multiply by itself to equal 4? That would be 2. And so we combine those two ideas and we get 4 to the power of minus 1/2 equals 1/2. So x is equal to minus 1/2.